everybody and welcome to my YouTube channel. I'm Michael and this is the first of two videos about a fixture I'm going to build to make it easier to change tools in the TTS, which stands for Tormach tool system, ER-20 tool holder. This first video will cover the design, the concept and the CAM, Fusion calls it, manufacturing process. The second movie will be about machining this part, so if you're more into flying chips, move to the second part. I also made another movie about cutter compensation. That's a process I'm using to dial in to rather precise press fits for two needle bearings. That's a separate video. It might be helpful to watch that first before you watch this one or the next one, because I'm using that process on the machine and it might make it easier to understand what I'm doing there. All right, so let's get started. Okay, so the idea is to create a fixture for the TTS ER-20 tool holder, which would allow me to keep the tool holder in place without the need to juggle two wrenches and the tool holder, but to keep it in place in a way that I can tighten or loosen this nut with one hand or with one wrench. The way to do that is you insert two one-directional needle bearings here. It's a needle bearing which can only turn in one direction, and the other one it's blocked. It's similar to the back axle of your bicycle. You can pedal in one direction, but you can freewheel it backwards. So you have two of these bearings, and you push in one in that way, and the other one you turn around in the other way, and then you pop in your tool holder here, and then you can tighten it, and you move it over to loosen it. That's the idea. The part itself, or the housing, is, like I said, it's made out of aluminum. This is just a wooden mock-up I made for this video. There's no critical dimension with one exception, or two exceptions. It's the two press fits for the needle bearing. The press fit needs to be tight enough to hold the needle bearing in place, that it's not rotating in the housing when you're tightening or loosening the nut. On the other hand, it cannot be too tight, because you still need to be able to press it in without deforming the needle bearing. If that would be a solid piece of steel, it's a little bit easier. You can use a lot of force to push that in, or you can hammer it in. Hammering in a needle bearing might be not the best idea, because you might destroy the housing or deform the housing, and then the needles can't move, and that renders the whole idea obsolete. All right, so like I said, that's the only critical dimension. I'm using a process called cutter compensation for that, which is more efficient and easier than changing the model all the time and creating new CNC files to dial in this dimension. I do that on the machine with PathPilot. And last, Tormach sells a similar part on their website. There's one big difference. The Tormach part only has one needle bearing. That means to tighten or to loosen this guy, for example, to tighten it, you pop it in from this side, and to loosen it, you pop it in from that side. But it also means that the only way to mount that is vertically. I want to mount it in this direction horizontally on my workbench, and that is a more convenient way for me to operate, and that's the reason why I designed my own part. Here's a model of the fixture in the Fusion manufacturing environment. I created 4 separate setups. One to machine the top and the sides. The second one is just to dial in the exact diameters for the two press fits. I'll get to that a little bit later. Then one to do the bottom, and finally the vertical is to create 2 holes in 2 counterbores. Let's start with the first one. Facing pass with the fly cutter. Then a 2D adaptive to clean up the sides. And the 2 holes for the needle bearings. I do the holes separately here in order to give me time to clear out chips. I don't want to recut chips all the time. So this strategy gives me time. I go in several steps here. It gives me time to clear the holes of chips. After the 2D adaptive, we do a 2D contour for the outside end for the two holes. Then we chamfer everything, and finally we engrave the words loosening and tightening. The next setup is just for machining the two press fits for the two needle bearings. I created a separate setup because for me it's easier to run a separate CNC file on the machine in comparison to looking up the exact starting line in a larger G-code file. So it's a separate file just for that operation. It's very simple. Control is with Path Pilot, and I can dial in these diameters at the Path Pilot controller. The process called cutter compensation. I made a separate video about that just to explain that procedure. Rather simple process. That's all it does. The next setup is for machining the bottom. I want to point out one issue, one possible issue. After machining the top, we have these two rather large overhangs left. And since I want to face it off with my fly cutter, this part is getting thinner and thinner. And I'm a little bit worried about the last pass of the fly cutter. This part is going to be very flexible then, and the fly cutter might not cut it, but crumble the material. So what I do is I first cut them off with a 2D adaptive and a 3/8 of an inch end mill before I use the fly cutter. There are of course different ways to do that. You could, since the part is off the vise anyway, you might just take it to your bandsaw and cut those off, or you could run the fly cutter from the other side, but then all the chips are flying in your face. Like I said, several options. That's the option I picked. It might be not the most efficient one if you go into serial production with a part like that, but this is a one part only project, so I went with that. Here's the simulation. First cutting off these two large overhangs. When that is done, we switch to the fly cutter and face it off in several passes. See, now the material is getting very thin, and I don't think that would cut it. Then we chamfer everything, and finally again I engrave with the words loosen and tighten. That way you can mount the part either that way or the other way around, whatever is your preference on which side you want to have loosen and on one side which side you want to have tighten. And finally the setup to machine these two holes and counterbores and chamfer everything and then create a little logo here. And that is it. A quick comment about the work origins for the different setups. I'm going to indicate the left back corner of my fixed jaw in the vise. And for the first setup, I set as work origin the left back corner and top of stock for Z. For the second setup, I leave it exactly as it was for the first setup because I don't take the part out of the vise. The third setup is the bottom, and then I set as work origin again the left back corner of the part, and for C I set the bottom of the model or the part, and for the fourth setup, which are the vertical operations, again set this left back corner, and for Z the top of this surface. This strategy allows me to keep the work origin at the left back corner of my fixed jaw and I don't have to probe it for every setup. The only thing I need to probe is Z. Okay, that's the end of this video. I hope it was helpful and you enjoyed it. The second part of this mini series will cover the machining of this part, and I'm looking forward to see you then.